In section 1.2, we are looking at the domain and range. We're also going to look at function arithmetic. Let's start with just the domain and the range. The domain is simply the set of inputs. We already know how to figure out what the inputs are. It's just another name for the inputs. It's the domain. The range is the outputs. Again, we already know how to find outputs. We just gave it a new name. It's called the range. So let's list the numbers in the domain of this function. When we list a set, we want to put it in curly brackets. Now, in your homework, they may have already supplied you with curly brackets, so just keep an eye out for that. If they do not supply you the curly brackets, make sure you type that in. So just a list of our inputs, so 2, 4, 6, and 8. And we're done with the domain. The range, a list of our outputs, 3, -5, 0, and 5. There may be problems in your homework where they ask you to put the range and domain in numerical order. So make sure you're doing that if they ask you. If they do not ask you, you shouldn't have to. We can also identify the domain and range in a table. So let's write our domain. Our domain is just the items that are in the first row. 0, 2, 5, 8, and 11. Our range is the items in the second row. 23, 54, 66, 87, and 108. Now, when we have a continuous function like in each of these, we have a graph of this function. We want to see in our domain how far to the left it is. That'll be our first number. Our second number is going to be how far to the right it is. So the domain actually contains an infinite amount of points, so we're not going to be able to just list out all the points. So what we're going to do is write the domain in interval notation. Interval notation is where we have first number, last number. If it's in parentheses, it means that it's all of the numbers in between these numbers, but not actually including these numbers. If we want to include x1 and x2, we're going to put hard brackets on them. Now we can mix and match these too. If we wanted to include x1 but not x2, we can have a hard bracket on x1 and a soft bracket on x2. And vice versa. If we wanted to not include x1, we could put in a soft bracket there. But we do want to include x2, we would put a hard bracket on the number we want to include. So how do we know if we want to include a number or not? In these graphs, the only time you do not want to include the number is when you have an open circle like this one, where the inside is white. That is literally the only time you do not want to include a number. So looking at this domain, how far to the right or how far to the left does it go? We want to start with the smallest number. It starts as low as -4, but we do not want to include that -4 because it has that open circle. So we're going to use a soft bracket. Now, how far to the right does it go? It goes to 5. It has a filled in circle here. That means that we can include +5. So we have a soft bracket on -4 and a hard bracket on 5. With the range, we want to see how low does it go and then how high does it go. So our range, looking down, starts as low as -4. Again, we have that open circle on -4, so we don't want to include that -4. How far up does it go? We don't want to just say it goes up to here, because you can see that the graph actually goes higher. There's no open circle up here, which means that we can include +4. So it goes from -4 to +4, hard bracket. Letter D is an interesting example. So this is a parabola. When you don't have the circles at the ends, you can assume that they go on forever. So this guy goes to the left forever, this guy goes to the right forever. So our domain, if it goes forever to the left, it's going to start at -infinity. And it goes all the way to the right. It just keeps going and going and going and going. It never stops, so it goes all the way up to +infinity. Now, infinity is a concept, not a number. So we can't include hard brackets on infinities. So we're going to put soft brackets on infinities. Every single time you have an infinity, it will be a soft bracket. Looking at the range, how far down does it go? Well, it goes down forever. So our limit on the bottom is -infinity. How far up does it go? Well, it doesn't go up forever. It stops at +6. There's no open circle on +6. Therefore, we can include +6.